Alright, here are solutions for quiz 5 for Math 95. One of these rowing problems. One of these distance equals rate times time problems. So the way we learn to do these in class is kind of set up a grid to organize all your information. So we got distance, we got rate, and we got time. But we have two of each of those. We have the distance going upstream and the distance going downstream, and the rate going upstream and the rate going downstream, and the amount of time going upstream and going downstream. And we can put all that information in this little grid. If you go through and read the problem, it says I rode 6 miles upstream. In other words, distance up is 6. And then 6 more downstream. Distance down is 6. Total journey took 4 hours. So if we call t the amount of time that we spent going upstream, because we don't know what that is, we can call 4 minus t the amount of time going downstream. In other words, 4 is the total amount of time. Everything that's left over from 4 after you take out how much time you spent going upstream is what's downstream. And then speed, what we're going to do is solve for how fast do you row when there's no current, or how fast do I row, I suppose. So we should give that a name. Maybe we'll call that x so that we can solve for x. And if we call that x, if x is my speed when there's no current, then if I'm going into a 2 mile per hour current, if I'm going upstream, my speed would be x minus 2. When I'm going downstream, it'd be x plus 2 when I have the current at my back. So what we're going to do is we have two equations and two variables, which is something we can solve. And we'll do it by substitution. So we want to solve for x, so we kind of want to get rid of these t's. And the way we can get rid of the t is by solving for t in this equation and then plugging that into this equation. So what I'm saying is if distance is rate times time, then time is distance divided by rate. All I did was divide both sides of this equation by r. And if time is distance over rate, I can set up two equations. Using my upstream information, I can say that time is the time upstream, which was 6, divided by the rate upstream, which is x minus 2. I can do that same thing with my downstream information. I can say, okay, the time there, which is 4 minus t, is got to be equal to the distance downstream, which is 6, divided by the rate downstream, which is x plus 2. And now what I can do is I know what t is equal to, so I can kind of substitute that in over here. And what that will leave me with is one equation with no t's in it. In other words, I can say 4 minus, but then instead of writing t, I can write what t is equal to, 6 over x minus 2. And that is equal to 6 over x plus 2. Do I want you to solve this? Yeah, I guess I asked you to solve this. I wonder if it would be better to just have you leave it at this stage. Now, gone this far, I'm going to have you solve this. So the way you solve this is you have a rational expression. You want to get rid of the denominators. So you figure out what the denominator is. In this case, the least common denominator is x minus 2 times x plus 2. Because you can think about this as 4 over 1. And that's the least common multiple between these three guys. So if my least common denominator is x minus 2 times x plus 2, that tells me that x cannot be equal to 2 or negative 2. Because in the next step in this process, I'm going to multiply both sides of the equation by my least common denominator. And if x were equal to either of these values, I'd be multiplying both sides of the equation by 0. I'd be losing all my information. Alright, so let's do it. If we multiply both sides of the equation by x minus 2 times x plus 2, you'll get 4 times x minus 2 times x plus 2 minus 6 times x plus 2. And that's all because the x minus 2 that should go here will cancel out with this x minus 2 right here. And similarly, on the other side of the equation, we'll get a 6 times x minus 2 because the x plus 2 that should go next to it cancels out with this x plus 2 right here. Now we get rid of parentheses. I guess first thing we can get rid of is x minus 2 times x plus 2 is x squared minus 4. And now we can get rid of the rest of the parentheses by distributing each of these three terms in. So 4 times x squared is 4x squared. 4 times negative 4 is negative 16. Negative 6 times x is negative 6x. Negative 6 times positive 2 is negative 12. 6 times x is 6x. 6 times negative 2 is negative 12. So now we combine like terms. See, we could, well, yeah, all right. I'll show one more step in here. 4x squared minus 6x minus 16 minus 12 more is minus 28. And then to solve this, I'm going to want to factor, but it only helps to factor if I have an equation set equal to 0. So I'm going to set this equal to 0 by subtracting 6x from both sides of the equation and then adding 12 to both sides of the equation. So that'll give me 4x squared minus 12x. And then we add 12 to both sides and get negative 16 over here. Negative 28 plus 12 is negative 16. So this is the equation that we have to solve. It looks hard to do because the leading coefficient's not a 1. However, we have a greatest common factor here of 4. We can pull out a 4 from all three of these terms, and we're left with just x squared minus 3x minus 4. And now that's a lot easier to factor because the leading coefficient is a 1 in front of this x squared. So I just need to find two numbers that multiply to negative 4 and add to negative 3. Those two numbers are negative 4 and positive 1. So this tells me that either x equals 4 or x equals negative 1. Checking with your least common denominator, we don't have to exclude either of those solutions. However, we don't want our speed to be negative. So x equals negative 1 wouldn't make sense as the solution. So our answer is that x equals 4. Maybe that gets a box around it or something. It's a long problem. All right, I guess moving on to the second one. So in the second problem, we're given an equation and asked to solve it. Sure. Okay. You know what I'm going to do? I'm going to change this quiz. No, I'm not. I'm going to keep going. All right. So I want you to solve this equation. So the way you solve this equation is we want to find the least common denominator. And the way you can find the least common denominator is by factoring all of the denominators. And all that amounts to in this specific case is this last one has a common factor of 2 between 2x and negative 6. If you factor out that 2, you're left with x minus 3. And now it's a little bit easier to see what the least common denominator is. It's just 2 times x minus 3. X minus 3, 2 times x minus 3 is our least common denominator. So what that tells us is x cannot be equal to 3. All right, let's go through and solve it. If we multiply both sides of the equation by 2 times x minus 3, sure, I'll write it all out. 2 times x minus 3 times x divided by x minus 3 plus 2 times x minus 3 times x divided by 2, the second term, is equal to 12 times x minus 3. 12 times 2, well, sure, let me write it in the same order. I don't want to be confusing here. 12 times 2 times x minus 3 divided by 2 times x minus 3. So this process is called clearing the denominator, because if we did it right, if we found the right least common denominator, we should be able to cancel out everything that's in the denominator here. And I think we can. This x minus 3 and this x minus 3 cancel. This 2 and this 2 cancel. This 2 and this 2 cancel. This x minus 3 and this x minus 3 cancel. So when all the dust settles, we're left with just 2x over here plus x times x minus 3 here, and that's got to be equal to 12. Okay, x times x minus 3, it's x squared minus 3x. So now we can combine like terms. Say I got an x squared, and then you got plus 2x and minus 3x. So that nets out to just minus 1x. That's equal to 12. To solve this off to factor, it only helps to factor if our equation's equal to 0. So what I'm going to do is subtract 12 from both sides of the equation to get to here. And then factor this guy. To factor this guy, what I need to do is find two numbers that multiply to negative 12 and add to negative 1. And the answer to that is negative 4 and positive 3. So this factors to this, which I can then solve. I can say, all right, either x equals 4 or x equals negative 3. So my answer, well, I guess I left out one step. We should then go back and check, go look up at our least common denominator up here. This says x cannot be equal to 3. That's okay. That wasn't one of our answers. We don't have to exclude anything. But so that's it. So that's the answer. X equals 4, x equals negative 3. That's the end of the quiz.